Welcome back, friends, to the course of C programming. So today I'm going to discuss the concept of arrays. What is an array and what is the need of an array? So the first two concepts will be what is an array, and second one is what is the need of an array. Yeah. So now let me explain the necessity of arrays in this class. I'll give the brief description of how to declare an array and all those things in C programming. Now, so take an example. Suppose if I'm going to uh, uh, enter one student information, then in student information, roll number is one important priority. Based on roll number, we can get the complete information. So roll number is called as key. So the student information may contain roll number, name, that is student name, phone number, and etc. Now let us assume that. So suppose if I want to declare a roll number, then I need an integer variable. Let us assume that the roll number is 1 to 60. There are 60 students in the class, 1 to 60. So I need an integer variable. So I have to create roll numbers like ID1, ID2, ID3, and so on, ID59, ID60. Likewise, I have to create the roll numbers for, that means I have to create the variables for 60 people. So now, is it possible? Is it required to create 60 variables? So this is variable 1. This is variable 1, and likewise we have up to variable 60. This is variable 60 we have. So now let us assume, so my scenario is if I create like this, 60 variables I am creating. Practically not possible. Let us assume that if I want to create the information for entire other IDs. So now will you create long int? Let us assume that long int is the variable to create the other ID. How many people are there in India? So 137 crore people are there. Is it possible to create other ID, that means ID1, ID2 up to 137 crore values? So why I declare the long integer is other ID is a 12-digit number. So that's why I declared it as a long integer. So is it possible to create 137 crore variables? Then what is the solution? So the solution is array. The solution is an array. Now see how to declare an array and all those things in this class I'm going to explain so clearly. So now solution is an array. Now what is meant by an array? Array provides a array provides a path to create a single variable for a set of collections for a collection of similar values. That means it is possible to create a single variable for a collection of values, for a collection of values of similar type. So now we can see here we are going to create a single variable and for a collection of values and of similar type. So now what is indicating that to create a set of integer values we need one single integer variable. Likewise, so that is the meaning of an array. But how this array will be stored inside the memory? How a one variable is sufficient? That I am going to clear now. So let us assume that I am going to create a short variable, short a. So if I create short a, what will happen? So I am going to allocate a memory of 2 bytes. So of which one byte is 0. Let us assume that 0x2000. 0x stands for hexadecimal, and the address, another address will be 0x2001. Since it is 2 bytes, 0x2000 and 2001 will be occupied. So this is going to store the lower byte data, and this is going to store the higher byte data. So fine. So how many bytes are needed? 2 bytes. Now similarly, an array is nothing but, suppose if I want to create an array of 5 values, then what will happen in the sense? So an array of 5 values is nothing but I'm going to allocate a memory of 5 values. Let us assume that one, 2, 3, 4 and 5. So this is an array of 5 values. Now let us assume that an array I want to create with 10 values of 10, 20, 30, 40, 50. These are the 5 values that I wanted to create. These are the values that I wanted to create in an array. So now 10, 20, 30, 40 in the sense, the first, let us assume that the address is starting at 0x2000. Now, so this is going to hold 2 parts. That is 10. 10 in the sense we know that 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0. Values, let us assume that 10, 11, 12, 13, 14, 10, 11, 12, 13, 14. So these are the 5 values. So this will be stored in the location of 0x2000, and this will be stored in the location of 0x2001 because of Little Indian format. That Little Indian, Big Indian, you will come to know in the later classes. So Little Indian, the lower byte will be stored in the first address and higher byte will be stored in the second address. Fine. Then similarly, this is 0x2003, 0x2002. This is 0x2005. This is 0x2004, 0x2007, 0x2006, 0x2009, 0x2008. So this will be 11. So that will be 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 1. Likewise, you can write all zeros. 0, 0, 0, 0, 1, 1, 0, 0. I'm continuing like that. All zeros, 8 zeros, that is 0, 0, 0, 0, 1, 1, 0, 1. So and this one is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 0. So now what is the starting address where this data is stored? 0x2000. This one 0x2002. This one 0x2004. 4. This one 0x2006. This one is 0x2008. Fine. Now that means this is 2 bytes, this is 2 bytes, this needs 2 bytes, this needs 2 bytes, and this one is 2 bytes. Total occupied memory is 10 bytes. Total occupied memory is 10 bytes. So an array of 5 values of short type needs 10 bytes of memory. Similarly, an array of, based on this one we can write an array of short values of an array of n short values, or otherwise n values of type short needs 2n bytes of memory. So one thing you have to remember, an array of n values needs of short type needs 2n bytes of memory. Similarly, this is applicable for anything. So an array of n values of dt type otherwise of a particular data type needs a memory of size of data type into n. So this is a standard formula. Now, so we have created collection of 5 values. Fine. This is 1, 2, 3, 4, 5. But in memory, so in variable we are going to give one access. The starting address we are going to remember, and this will be stored into variable. If a variable remembers the starting address, so that means an array variable is called as a reference variable which holds the address. Remember that an array variable is a reference variable which holds an address instead of value. Now, so these values are stored in the locations of 2000, that is 0th index and first index, second index, third index, fourth index. So these are called as indices. So 0, 1, 2, 3, 4 are called as indices. So we have 5 indices, 0 to, it is starting at 0 and ending at n minus 1. So that means if an array is having n values, then index will start at 0 and ends at n minus 1. So what will end? So it is if n values then index will start at 0 and ends at n minus 1. Then that is the one important thing. And the second one is, so if your particular data type is having, so if an array is having n values of a particular data type, then the memory is equivalent to size of the memory it is the array is occupying is equivalent to size of data type into n. So these three things that you have to remember. Now, how to declare an array in C? In C, how to declare an array? Now it is possible to declare an array. This is the syntax. You have to follow this syntax while declaring an array. So the syntax is a data type followed by variable name of size of an array. That means how many elements. How many elements of an array or how many values. That is mentioned as size. This is one syntax and this is for declaration. And if you want to declare and define, then syntax is data type followed by variable name of size n, which is equivalent to, so values from value 1, value 2 and so on, value n. So these are the n values. So each value is separated by commas and all the values will be incorporated in braces. All values will be incorporated in braces. So this is the syntax. For instance, example. I'm explaining one example. So suppose if I'm going to create a short variable, a short n array. So short a of 5. This is for first. And second one is short a of 5 is equivalent to 1, 2, 3, 4, 5 values. And one more thing that I wanted to mention, whenever you are declaring and defining, for this case you need not mention the size. Automatically it will take the size. Size in subscript. What is this new term? So this is called as subscript. Subscript is nothing but open closing braces is called as subscript. Fine. What I'm going to say here is, so you can create the same thing as short a of is equivalent to 1, 2, 3, 4, 5. This is also correct in this case. Automatically based on the number of values, the size will be allocated. But this is not true in this case. You have to mention the size. The same thing is not true in the first case. Fine. Now, fine, we are going to create one array and we shall see how the addresses will be allocated. So let us assume that I am going to create an array with the values of 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So there are 5 values. Let us assume that 1, 2, 3, 4, 5. The indices are 0, 1, 2, 3, 4. So let us assume that this variable is A. So I'll explain how an array will be created with the program. See, this is a program. Let us assume that I'm going to write hash include stdio.h int main. So then short a of equal to 1, 2, 3, 4 and 5. These are the 5 values. Let us assume that, so if I wanted to print all the values, so printf %d a of %hd, since it is a short, backslash a of 0, printf backslash n percentage hd a of 1. That means I am accessing the first variable, so the first value, printf backslash n percentage hd a of 2 a of 3 and a of 4. So fine, let us assume that this is the program. So yeah, we had seen that a of 0 or 0 of a both are same. Now suppose if I want to print the addresses of this each and every location, that is 1 2 3 4 5. You can see short, each should occupy 2 bytes. So as I told, so I'm running this program. Sorry, the addresses will be like we have to print like a. So that means this one is a plus 1, this one is a plus 2, and this one is a plus 3, then this one is a plus 4. Now see the address, how the addresses will be printed. Yeah, so the addresses are 61FE F6, 61FE F8, 61FE Fa, 61FE Fc. Previously 2 zeros are there because it's a 16-bit address. So sorry, 32-bit address, 18 to 4. That is each hexadecimal. All these are hexadecimal values. So one hexadecimal digit is equivalent to 4 bits. So 18 to 4, 32-bit address. This one is, since since integer occupies 32 bits, the same thing has been mentioned here. 61FE Fa. So 00 is not considered. In case of percentage b, 00 also will be printed. So it's a 32-bit address. That's why 6 plus 2 8, 8 plus 2 is a plus 2 is c plus 2 is e. So totally each location is occupying 2 bytes of addresses. So what is the address? Starting address 0x61FE F6. The starting address is 0x 61FE F6. 61FE F6. This one is 61FE F8. 2 bytes. 61FE FA. This one is 61FE FC. This one is 61FE F ABC. So CDE. So likewise, these are the 5 addresses. Now what we have seen, so starting address is A. Whenever I am calling A, it is equivalent to starting address, that is 61FE F6. I will get the value of 1. Now this is A plus 1, sorry, A plus 0, this is A plus 1, this is A plus 2, this is A plus 3, this is A plus 4 addresses. Okay, so now suppose this address is equivalent to A plus index. Sir, you are saying that A plus index, but A plus index is nothing but F6 plus 3 should be F6 plus 03 should be F9. No, so why it is FC? So this calculation is wrong. So A plus index is nothing but A plus index into size of data. That is nothing but, so FE F6, that is the base address, plus 3 into size of the data type is 2, that is equivalent to 6. So FE F6 plus 6, which is equivalent to C. That means FEFC. Similarly, the content is, this is A of 0, this is A of 1, this is A of 2, A of 3, A of 4. How it data will be accessed? Suppose if you are giving A of 2, then it is nothing but base address plus 2 into, what is the size of the data type? Size of short. What is the size of short? That is 2. So that is equivalent to base address is FE F6 plus 4. That is nothing but FE FE. So now A of 2 is nothing but the content is available in the location of FE FE. So the standard formula is A of index is nothing but base address plus index into size of data type. If it is integer 4, long int 8, so that is depending on the data type that you are going to use. Size of data type. So now you can see, I'll give the same demonstration with integer. So integer data type occupies 4 bytes. So now whenever I am giving integer, see, I'm going to run this program. Initially FC, then C plus C. FC is the starting data. So C plus 4 is equivalent to 10. 10 or F, C, D, E, F and 10. So that's why it is F means the next value will be 10. Or it can be 00 because F is there, so it is 100. The next value will be 00. The next value will be 04. The next value will be 08. The next value will be 0C. These are the addresses you can see. So this is EC. The next one is F0 because of 1 is added here, 10. So 10 means it is nothing but E plus 1 is F0. The next one is F4. The next one is F8. The next one is FC, as I mentioned. Sorry, I have written it as the wrong value. It should be EC. EC. So EC plus 4 is nothing but C plus 4 is always 10. So EC plus 4 10. E plus 1 is F. So this will be F0. This will be F4. This will be F8. This will be FC. That's why these are the addresses. Now suppose if I give long integer. Long integer occupies 8 bytes. Now see, sorry, I didn't see it. So EC F0. Why it is F0 again? EC F0, F4, F8. It's long integer. Yeah, I had given percentage expect only. So why it is giving? Okay, maybe this code blocks is taking only 4 bytes for long integer, it seems. Now I will give long integer. Now you can see D8. D8 plus 8 is E0. E0 plus 8 is E8. E8 plus 8 is F0. F0 plus 8 is F8. Sorry, this code blocks is taking long integer as 4 bytes. That is the GCC, that will depend on the GCC version. So here it is 4 bytes. So previous turbo C integer is 2 bytes only. Now short is 2 bytes, integer of 4 bytes. So that you need not worry. So this is you have to remember only the concept. So now what you understood. So then similarly, if you want to access any value, then it is equivalent to A of 0. So I'm giving it as a HD. I'm removing the remaining data. So I'm removing the remaining data and the control C. So control V. So if I give A of 3, it should be 4. What will happen if I give \n %HD A of 5? So what are the indices that we have? So we have the indices from 0 to 4 only. So how can I give 5? It's not possible. So if I give 5, what will happen? Then it will print the garbage value. Then it will print the garbage value. One it is printed, that is A of 0, and A of 3 is 4, and A of 5 is 58, which is a garbage value. And similarly, suppose if I give -1 also, then also it will print the garbage value. So 1466. So that means whenever we are declaring an array, we have to ensure that so there will be a memory location, previous memory location, which we don't know, garbage value, and there will be after memory location, which we don't know, garbage value. So this is a basic idea that I am going to give for the arrays. So in next class I will explain different operations on the arrays, as well as how to access that means how to write a program for sorting and all those things I can explain in the next video. So friends, thank you for watching my videos. So I'm trying to give all the conceptual, that is all the information, so at conceptual level and memory point of view. So if you are liking my videos, kindly like and subscribe and share. Thank you so much.